guy by the name of Casimir was the guy that derived that back in 1948, but it took us until the late 90s to actually measure this in the lab to the physics community's satisfaction. And so it's been studied hundreds of times since, measuring forces at different regimes, if you will. And there's also something called the transverse Casimir force. So when you try and slide those two plates relative to one another, the vacuum wants to resist you sliding those two plates. And so this is a very real phenomena, and it's a wonderful illustration of the peculiar nature of reality at the microscopic level, right? So, the theory was worked out in the late 40s. The experimental stuff was started in the 90s, and then there's been a bunch of work since then. And I think they're even looking at trying to use the Casimir force in MEMS devices. But all that to
what is the MEMS?
Micro electromechanical machines, some small gears that you can't see with your eyes, but they serve different purposes that people are trying to come up with for sensors, maybe some things in your car, some future chips that might be in your phone or something like that. Things where they make micromechanical systems that they make them with light because you can't even see those kinds of things. So the quantum vacuum, this fluctuating field of particles and forces and so forth, is a very real phenomena. And so this stuff I just described to you is the negative vacuum energy density that Alcubierre highlighted in his paper when he said, we don't know how to make exotic matter in general relativity, so that circle on the Venn diagram doesn't tell us where to go. But quantum mechanics tells us how to make negative vacuum energy density in the context of what we see in a Casimir cavity.